Hello. Eukaryotic translation is complex and there are multiple steps involved. We need the processing of the mRNA itself or prepare it for the mRNA for translation, and at the same time prepare the small subunit for initiation itself. And then we have a pre-initiation complex formed between the mRNA and the small subunit, upon which the large subunit will form, and then we have a complete initiation complex formed. There are multiple factors involved, and we'll try to have a look at them. So to start off, the initiation factors when it comes to eukaryotes is referred to as the the EIF. E stands for the eukaryote, and IF capitals are initiation factors. So like in the prokaryote case, we also have initiation factors 1, 3 and 5, and even we have multiple other accessory proteins, something like EIF1, 1A, etc. So they all have functions very similar to that of what we have discussed for the prokaryotic initiation, like 3, 1 and 1A and 5, etc. So to it we have EIF2 along with GTP bound to it, and also the initiator tRNA together as a complex. It's like the EIF2 in the active conformation, when it is bound to GTP, brings the initiator tRNA along with it and puts it near to the P site, that's the peptidyl site of the small subunit, and that is what is called as the 43S pre-initiation complex. It constitutes the small subunit. It has EIF3, which is a large subunit, as you can see, and then we have 1, 1A, 5, 2, etc., and along with the initiation factor, initiator tRNA. The mRNA of eukaryotes has to be recognized, and one of the ways it is recognized is by the G cap that is present. So all mRNAs have all eukaryotic mRNAs have G cap, unlike the rRNAs, tRNAs and other small RNAs will not have this G cap. So that is how these are recognized, and the factor that binds to it is the factor EIF, which binds to the G cap, and then we have recruitment of several other factors like EIF4G, 4A, etc. The eukaryotic mRNAs are large, and they could be folded upon themselves, something forming secondary structures, something like this. And the start codon could be somewhere here, as indicated here. So the initiation factors EIF4G, 4A, etc., they bind here, and they are kind of now preparing the mRNA for initiation to be bound by the 43S pre-initiation complex. So when E and G, A and EIF B, they are all together, that is what will be bound or recognized by the 43S subunit pre-initiation complex, and they bind together in something like this. So now what we have here is the pre-initiation complex loaded onto the mRNA with these other additional initiation factors. But the initiator tRNA is not bound to the start codon yet. So somehow the anticodon of the initiator tRNA should come to the start codon, that is AUG here. So what the small subunit does is kind of scans through the mRNA, which is an active process, meaning that it requires energy for scanning. It has multiple things to do. It has to resolve the secondary structures that may be in the mRNA until the start codon has come by. So upon scanning and upon encountering the start codon, and when the start codon, so this is the looping of the mRNA happens. The mRNA scanning of all this mRNA has been scanned, and the scanning will continue until the start codon comes to the P site of the small subunit. I mean, that is where the initiator tRNA is also there. The recognition is easy because the initiator tRNA and the start codon would be a perfect base pairing. And once that happens, that is when this pre-initiation complex will lose several of these factors like EAF 5B, 2, 1, 5, 4B, etc. That will result in that will allow the time for the space for the 60S subunit, that is the large subunit of the eukaryote, to be loaded onto the ribosome, the small subunit. That is when the small subunit will lose the affinity for the GCAP, and it will leave behind those things and will start translation from here onwards. The initiation or proceeding from initiation to elongation would also require the hydrolysis of the GTP that is bound to EAF5B, and that will allow the release of 1A and also the 5B, because of which now we have the ribosome positioned on the start codon in its P site, and there is an empty A site for the incoming tRNAs based on the second codon, whichever it is, the appropriate one. And that is when elongation takes over. I hope we appreciate that there is complexity. We don't have to really memorize all of them, but it will be nice to appreciate that these are the mechanisms that are available, and maybe we all might forget a little bit of detail, but that's all right. The mechanism is something that we need to remember, because they will recur in many other processes that we might study in the future. Thank you. See you again.